Hello everyone. Here is a new Leetcode problem which name is Cherry Pickup 2 Leetcode1463 problem. So as you can see it's a hard problem, but I will say it's not a hard problem. If you know the concept, if you think a little bit about this, then it will be easy for you. So let's read the problem statement. You are given a row into columns, matrix grade representing a field of cherries where grade of ij represent the number of cherries that you can collect from the ij. Okay, cell. You have two robots that can collect cherries for you. That's why it's a hard problem because we have two robots. So we have to traverse from two sides. In normal way, what we do is what we'll see that we have only one robot, but here we have two robots. That's why it's a hard problem. So robot 1 is located at the top left corner 0, 0, and robot 2 is located at the top right corner, means 0, column minus 1 and minus 1. Means robot 1 is there, robot 2 is there. So return the maximum number of cherries collecting using both robots by following the rules. There are three rules. So from a cell I comma j, robots can move to cell I plus 1 comma j minus 1. I plus 1 comma j minus 1 means next row or previous column. It is next row, current column, and it is next row and next column. So when any robot passes through a cell, it picks up all the cherries and the cell becomes empty cell. Means when the robot passes through a cell, then it will take all the cherries, and then it's definitely the that cell will be empty. So when both robots stay in the same cell, only one takes the cherry. It's obvious. जब दोनों रोबोट एक ही सेल पे होंगे तो कोई एक ही चेरी लेगा वो है. Both robots cannot move outside of the grid. हाँ, we know. Both robots should reach the top bottom, means bottom row in grid. That is a base case for this. Okay. So let's see the approach for this and example. Yeah. If we have this matrix, like if we zoom this. Hmm. If we have this matrix, so robot 1 and robot 2 can move uh, next I plus 1 comma j minus 1 means next row current column, previous column, sorry, then I plus 1 comma j next row current column, and I plus 1 comma j plus 1 next row next column. Here as you can see, I plus 1 is common, means both the robots are going next row. So previous row में कोई नहीं जा रहा, next row previous column, next row current column, next row next column. Means if this is my robot, so ये इधर भी जा सकता है because next row दोनों robot next row में तो जाएंगे. अब कॉलम चेंज हो रहा है, नेक्स्ट कॉलम भी हो सकता है, करंट कॉलम भी हो सकता है, प्रीवियस कॉलम भी होता है. इफ इट इज प्रीवियस कॉलम देन इट विल गो this side, this side, yeah. And it is a current column, so it will go this side, and if it is a next column, then it will go this side. So as you can see here, if I comma j, if robot is at the index of I comma j, if robot 1 is going in this direction I plus 1 comma j minus 1, now robot 2 has three choices. Either it can go in this direction I plus 1 comma j plus 1, either it can go in I plus 1 comma j, means current call next row comma current column, and next row comma previous column. If robot 1 will go in this direction I plus 1 comma j, then we have three choices, then again we have three choices. So it's like a total number of recursive calls will be 3 into 3 9. If only one robot will be there, then the total number of recursive calls will be 3. Now two robots are there, and one robot, if one robot is going in this direction, then we have three choices for robot 2. So that's why it's a 3 cross 3 n cross n recursive call. So let's see this. If robot 1 is here, I told you about this. This is not a row. It's a 4 cross 3 matrix. So ये तो गलती से बन गया, ठीक है. If robot 1 is at here, means in this index, या इस index पर robot 1 पड़ा हुआ है, ठीक है. robot 2 कहाँ पे है? Top right corner पे, मतलब यहाँ पर robot 2 है, ठीक है. If robot 1 will go, either it can go in this direction or in this direction. It can't go in this direction because if it will go in this direction, it means next row previous column, then it will go out of the bound. That is not a good case. So either it can go in next row current column or in next row next column. If it will go in next row current column, I have created this as a final answer. That's why it can go in this direction also. So if it will go in this direction, then in this direction, then in this direction, as you can see, both robots have to go in next row, only columns are changing. So if a robot 2 is going in this direction, either it can go in this direction or in this direction. So robot 2 is going in this direction, then in this direction, then in this direction. So whatever means, जिस भी इंडेक्स से ये दोनों निकल रहे हैं उसकी चेरीज को ऐड करते चलेंगे। फिर रोबोट 1 के पास चेरीज कितनी हो जाएगी, 3 plus 2 plus 5 plus 2 means 12. Robot 1 has earned 12 cherries, and also robot 2 is has earned 12 cherries because 1 plus 5 plus 5 plus 1, 12 cherries. To 12 plus 12, 24 will be our answer. So that is the recursive call. Now let's see this code. It's a easy code. See here, as you can see, कि I plus 1, both robots have to go in next row, means दोनों रोबोट को नेक्स्ट रो में तो जाना ही पड़ेगा. सो वाई टू टेक another variable? It's like only columns are changing. So कॉलम के लिए हम ट्रेवर्स कराने के लिए दोनों रो के लिए y1 y2 ले सकते हैं, ठीक है. बट दोनों रोबोट सेम रो में तो जा ही रहे हैं, मतलब नेक्स्ट रो में जाएंगे, उनको जाना पड़ेगा. सो दैट्स व्हाई वी कैन टेक ओनली वन वेरिएबल x. So no need to take two variables. You can take two variables also, but no need to take two variables because the both robots have to go in next row. That's why only one variables is easy. Yeah. So now let's see the code for this. Now here I have initialized the size of the array. It's a row and it's a column size. Okay. Now we have created a 3D DP. Why 3D DP? Because I have told you about this key I plus 1, because both robots have to go in next row. So no need to take another variable. So एक n which is a row लिख देता हूँ, रो साइज, ठीक है, जो कि n रो साइज है और ये है कॉलम साइज, ठीक है, m. सो रो साइज तो मैंने एक n ही ले लिया, और कॉलम साइज के लिए दोनों के लिए कॉलम अलग अलग है, बिकॉज both robots can go in different directions in column wise. I'm talking about column wise. So that's why I have taken m और m means दो dp इसके लिए बना दी. So it's a 3D dp. Now let's write the function for this dfs function. Why I have taken n comma m comma 0 comma 0 like this? Because n and m is the size, 0 0 is the index of which is showing the row, only row. I've told you about this. I am taking only one variable, that's why this is the index for row. So this is the index for row, and 0 comma m minus 1 is showing, uh, let's see like this. Here column is 0, here column is 0, and here column is m minus 1, because m is showing the size of the column. So m minus 1 means I have taken three variables. Mm, no need to take four variables. You can take four variables like 0 comma 0 x1 x2, एंड y1 y2 के लिए 0 कोमा m माइनस वन, ये तो सेम ही रहेगा. ये y1 है और ये y2 है और ये x है जो कि मैंने कॉमन ले लिया है, ठीक है. Now let's write the function for this DFS function. So this is the base case for this. I have told you about this. If both robots should reach the bottom row in grid. If both robots like if the robots will go out of the bound. If like row is less than 0, row is greater than equal to n, and same as column 1 is less than 0, column 1 is greater than equal to m, or column 2 के लिए भी same condition. If this occurs, then we have to return 0. So this is the memorization कि dp of row r is the row, because row is same, because both robots have to go in next row. So no एक ही वेरिएबल ले लिया उसके लिए. So dp of row कॉलम 1 कॉलम 2 नॉट इक्वल टू -1, सो इसको रिटर्न करा देंगे. नाउ एक वेरिएबल लेंगे इंट मैक्स सेरीज. मैक्स सेरीज क्यों लिया वेरिएबल? क्योंकि हमें तो रिटर्न कराना है मैक्स सीरीज, ठीक है. तो मैक्स सीरीज वेरिएबल ले लिया, इसमें ऐड करते जाएंगे. वाई आई हैव टेकन दिस -1 to 1, because if it will go -1 0 1 3 direction, because we have three choices ना, current, either it can go in next row, previous column, next row, current column, next row, no, next column. It can go like a 0 to 2, और it also can 0 to 2, मीन्स ये बस सिंपली इसलिए लिखा गया है -1 to 1, 0 to 2 भी हो सकता है, 1 to 3 भी हो सकता है, मतलब 3 बार लूप चलना चाहिए मेरा, इसलिए यहाँ पर 3 बार चल रहा है, -1 के लिए, 0 के लिए और 1 के लिए, तो 3 बार लूप चलना चाहिए, दैट्स वाई आई हैव रिटन दिस -1 to 1. You can write like 0 to 2, 1 to 3 like this, okay. So in the new column 1 equals to column 1 plus I, and column 2 equals to column 2 plus j, and this is a function call. We have to find the maximum number of cherries. So max cherries equals to maximum number of cherries, comma DFS function. DFS function, I have to increase the row. In every case I have to increase the row. So n comma r plus 1, or this is a new column 1, or this is a new column 2, column 1 plus j, column plus I. That's why I've written like this. Now we have to create int current cherries. Why I have written like this? I've written like this because if this condition holds, when both robots stay in the same cell, only one takes the carries. अगर दोनों रोबोट एक सेल पर आ जाते हैं तो कोई एक ही चेरी लेगा. सो इंट करंट चेरी इक्वल टू कॉलम 1 इक्वल टू कॉलम 2, मीन्स दोनों एक ही कॉलम पर आ जाते हैं. अगर ये कंडीशन ट्रू हो जाती है तो कोई एक ले लेगा, मीन्स ग्रेड ऑफ आई आर ऑफ कॉलम 1, ये कॉलम 1 ये ले लेगा. अदरवाइज इफ डिफरेंट कॉलम पर होते हैं तो दोनों लेंगे उस पर्टिकुलर, जैसे ये वाला रोबोट किसी और कॉलम पे, ये वाला रोबोट किसी और कॉलम पे, तो दोनों अपनी अपनी चेरी से ले लेंगे. सो ग्रेड ऑफ आर ऑफ कॉलम 1 और प्लस ग्रेड ऑफ आर ऑफ कॉलम 2, and this is the memorization to return this, and this was the complete code. So now let's run this code and see if this will work or not. It is working perfect. Let's submit this code. Yeah, it is working perfect. Now let's talk about time and space complexity for this solution. So as you can see here, so firstly let's talk about space complexity. So it's a 3D DP. So it is going from the space complexity will be big of n into m into m. If we will take if we took like x1 x2, I have यहाँ देख सकते हो, I have taken the three variables. Row row is the same variable. Column 1, column 2. That's why it's the space complexity big of n into m square, m into m. So n into m square. If you will take the two variables for column, two variables for row, then the space complexity will be big of n square into m square. So here the space complexity big of n into m square, and the time complexity is also big of n into m square. So this was the complete code. If you find this helpful, then please like, share and subscribe.